Sugar looks simple. A small spoonful disappears into a drink. A handful melts into a cake batter. A few crystals brighten up a bowl of fruit. But the sweetness you taste has traveled a long way before it reaches your kitchen. That journey starts in sugarcane fields, where tall green stalks store sunlight as natural sugar. When the cane is ready, harvest crews move in at just the right moment, because timing affects quality. Sugarcane is usually cut either by hand or by harvesting machines that slice the stalks close to the ground. The goal is to collect cane that is fresh, clean, and as undamaged as possible. Too much broken cane can spoil faster, and too much dirt and leaf material can make processing harder. Once the cane is cut, the clock starts ticking. Sugar in the stalk can begin to decline as the plant continues to breathe and as naturally occurring microbes start to break sugars down. That is why the next step is speed. Cane is loaded onto trucks or trailers and transported to the sugar mill as quickly as possible, often the same day. Freshness is one of the most important ingredients in the entire process. At the factory, the cane is received and recorded. Trucks are weighed so the mill knows how much cane has arrived. Then samples are taken to measure quality. The mill checks sweetness and fiber levels, and it also looks for unwanted material like soil and dry leaves. These checks help the mill adjust the process for the day's cane and ensure consistent product quality. In many supply systems, sampling also helps determine fair payment based on the cane's sugar content. After receiving, the cane moves into preparation. Before the sugar can be recovered, the mill needs to open up the stalks and expose the juice inside. The cane is fed into heavy-duty cutters and shredders that chop the stalks into smaller pieces and pull the fibers apart. This increases the surface area, so the next step can pull out as much juice as possible. Then comes extraction, one of the most powerful stages in the factory. Prepared cane is pressed through a series of rollers that squeeze out the juice. Some mills help the process by spraying in controlled amounts of warm water or recycled juice to rinse sugar out of the fibers during pressing. What comes out is a stream of raw cane juice, sweet but still full of natural plant material and impurities. What remains is a fibrous leftover called bagasse. Bagasse is not waste. In many sugar mills, bagasse becomes a valuable fuel. It can be burned in boilers to produce steam and electricity that helps run the factory. This is one reason sugar mills are often able to generate a significant part of their own energy, turning a leftover into a resource and reducing reliance on outside power. The raw juice now needs to be cleaned. Even though it contains the sugar we want, it also contains fine particles, waxes, proteins, natural pigments, and tiny bits of fiber. If these impurities stay in the juice, the sugar can become darker, smell off, or crystallize poorly. So the mill clarifies the juice using careful chemistry and temperature control. First, the juice is adjusted to the right conditions so impurities can be separated. A common approach involves adding a small amount of lime, which helps neutralize acidity and encourages unwanted compounds to form larger particles. The juice is then heated to help reactions happen efficiently and to prepare it for separation. As the impurities gather together, they can be removed through settling and filtration. The result is a cleaner, clearer juice that still carries its sweet core, but is now much more suitable for making good crystals. The removed solids do not have to be thrown away. Filtered material can be processed into a byproduct often used as a soil amendment in agriculture, depending on local practices and regulations. Just like bagasse, this is another example of how sugar production tries to use as much of the plant as possible. Now the factory prepares the clean juice for crystallization. This is where sugar changes from a liquid into the familiar grainy crystals we recognize. Crystallization is a controlled process, and the goal is to guide sugar molecules to join together in an organized structure. To do that, the liquid must reach the right conditions. And then the factory introduces tiny starter crystals called seed. These seeds give the sugar something to build onto, like a scaffold that helps crystals form evenly. Inside large vessels, the liquid is kept under carefully managed temperature and pressure, allowing crystals to grow gradually. Operators watch the process closely because crystal size affects the final product. Larger crystals may be preferred for some uses, while smaller crystals dissolve faster and are preferred for others. The art of crystallization is all about balance. Grow crystals well, avoid unwanted color pickup, and prevent the mixture from turning into an uncontrolled mass. As crystals grow, the mixture becomes thick. At this point, it is no longer just liquid juice. It is a dense blend of sugar crystals suspended in a syrupy mother liquor. The next job is to separate the crystals from that syrup. Separation happens using high-speed spinning in machines called centrifuges. The thick mixture is fed into a spinning basket that forces the heavier crystals outward while the liquid syrup moves away. The crystals remain, and the syrup drains out. That syrup, depending on the stage of processing, can be boiled again to recover more sugar in additional rounds. Eventually, when most recoverable sugar has been extracted, the remaining syrup becomes molasses. Molasses is another important byproduct. It still contains sugar, minerals, and flavorful compounds, but it is too concentrated in certain substances to crystallize easily into standard sugar. Molasses may be used in food products, animal feed, or fermentation industries, depending on local markets and factory design. After centrifuging, the sugar crystals are still damp. They may carry a thin film of syrup, and they contain moisture that must be removed for storage and transport. So the crystals are dried using warm air in large drying systems. Drying must be controlled to prevent melting, clumping, or color changes. Once dried, the sugar is cooled, so it will remain stable and free-flowing. At this stage, the product may be a raw or less refined sugar, often with a light golden color. If the goal is white refined sugar, the crystals go through further refining steps. Refining focuses on removing remaining color and trace impurities to produce a brighter, more neutral tasting sugar. Refining often begins by dissolving the sugar crystals again to create a sugar solution. That solution is then purified using filtration and specialized cleaning methods that remove color compounds and tiny residues. One common approach uses carbon-based filtering media or resins designed to capture pigments and impurities. The solution is then crystallized again under controlled conditions to create refined white sugar crystals. After a final separation, drying, and cooling, the sugar is graded. Grading means sorting sugar by crystal size and checking it against quality standards. Factories test for moisture content, color, purity, and safety. Moisture matters because sugar that is too moist can clump or spoil more easily. Color matters because it affects the appearance of products made with it. Purity matters because it affects taste, performance in cooking, and stability. Quality control continues throughout the process, not just at the end. Samples may be taken at multiple points to ensure the factory stays within targets. Many producers operate under food safety systems that focus on cleanliness, traceability, and consistent standards. Equipment is cleaned regularly, and processing conditions are recorded so that product quality can be verified and improved over time. Now, the sugar is ready for packaging. Packaging is more than just making it look nice on a shelf. It protects sugar from moisture, odors, and contamination. Sugar is usually packed into different formats depending on its destination. Small bags for households, larger sacks for restaurants and bakeries, and bulk shipments for food manufacturers. During packaging, machines measure precise amounts, fill bags, seal them securely, and print batch information. That batch information is important for traceability. If a quality issue is ever discovered, the producer can identify when and where a particular lot was made and where it was shipped. Next comes storage and distribution. Packaged sugar is stored in dry conditions to prevent moisture absorption. Warehouses are designed to keep sugar clean and stable, away from strong smells and humidity. From there, sugar travels through distribution networks by truck, train, or ship, depending on distance and scale. Some sugar goes to wholesalers, some goes directly to supermarkets, and a large amount goes to factories that make soft drinks, biscuits, chocolate, sauces, dairy desserts, and countless other products. Eventually, sugar reaches the final stop. You. It appears in your pantry, your favorite cafe, or the ingredient list of foods you buy. And even though it arrives as something ordinary, it carries a story of agriculture, engineering, chemistry, and careful control. What makes this journey especially interesting is how much of the sugarcane plant can be used. The sweet juice becomes sugar. The fibrous bagasse can power the mill. The remaining syrup can become molasses. Filtered solids may return to fields as soil support. In many places, the sugar industry is not just a single product line, but a connected system where outputs from one step become inputs for another. So the next time you stir sugar into a drink, take a second to imagine what it took to create those crystals. Sunlight captured in a stalk, a fast harvest to protect freshness, powerful extraction to release the juice, careful cleaning to remove impurities, controlled crystallization to shape sweetness into grains, drying, refining, testing, packaging, and distribution until it ends in a moment so small it's easy to overlook. A spoonful, a sprinkle, a taste. That is the hidden journey of sugar, from sugarcane moving from field to factory, and from factory to your table, so that sweetness can become part of everyday life.